Howdy folks. Today we're going to be taking a look at Advent of Code 2024. I've heard of Advent of Code for a couple years, but this is the first time I've actually really tried to do it. It's kind of a little bit like an Advent calendar. You can see here we have, it happens to be the 21st today. So we've got 1 through 21, and it's all the way until Christmas. So it gives you a new little challenge to do every Christmas, kind of like opening an Advent calendar, which is, I think, kind of cool. Um, if you're watching this video, you might know this. It's after this is finished, and that's because I'm recording these now, but I'm going to release them after Advent of Code is over, just so that I don't, spoil the surprise for anyone who is actually trying to accomplish these on their own. So, let's get started with number 1. Okay, day 1, Historian Hysteria. There's a big blurb of stuff here. This is actually kind of a long word puzzle. They have locations mapped with a star. Chief historian must be in the first 50 places, etc., etc. It's kind of hard to read through here and figure out what they actually want us to do. But if we look down here, okay, we have lists, and these lists have a location ID. It's nice for them to actually bold these things so that we can really look at it. If you really want to understand and like read through this problem yourself, please feel free. I'm not going to spend 10 minutes reading through it again. So we have these lists. Lists are off by a small amount, pair up, and so here's where we actually get to the problem they're asking us to solve. Pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, second smallest left number with second smallest right number. Right away, that tells me that I need to figure out like 1 here goes with 3, 2 here probably goes with 3 also, 3 here goes with 3 because there's a bunch of 3s, 4 with 4, or no, a bunch of 3s here. So we have 1, 3, 2, 3, 3, 3, 3, 4, 3, 5, and 4, 9. Okay. Within each pair, figure out how far apart the two numbers are. You'll need to add up all those distances. For example, if you pair up a 3 with a 7, the distance is 4. Pair up a 9 with a 3, the distance bar was 6. So once we get these all paired up, we need to basically subtract the smaller one from the bigger one, and then sum all those distances. So they give us the example here. Smallest number is 1, smallest number is 3, right? 1 and 3, the distance between them is 2. 2 and 3, which is 1, 3 and 3, 0, 3 and 4, 1, 3 and 5, 2, and 4 and 9, which is 5. So we have 2, 1, 0, 1, 2, 5. The total distance sums all of these together with total distance of 11. Now, this is kind of interesting in that they're asking you, what's the total distance between your lists? They're not actually asking you what the code is. So this is not like, I haven't looked at any of the others, but this particular one is not like leak code in the case where they're actually looking at your algorithm, running it through tests. They're just saying, figure it out. So if I look at get my puzzle input, you could possibly do this manually. Right? It is totally possible that you could do this manually and get something, but it's probably not what you'd actually want. So let me just copy this. This is going to be my input. So I have my code here. And I'm going to try to put this into a CSV. So this is obviously not CSV format. There are 3 spaces here. So what I'm going to do is I'm going to do a replace on those spaces and replace them with a comma. There we go. Now I have a CSV. Okay, so the first thing I have to do is actually get this data in. It's not right now in the correct format. It's CSVs are done in rows, and this is lists of columns, right? So I want each column to be in its own array. So let's just pull that in. And we'll grab fs and path. Oops. Okay, and then input file, path.join, and input.csv. Okay, so now let's just grab all the data. I think there might actually be a node module that just reads in CSV data, but I don't actually know how to use it off the top of my head, so just pull it in line by line. So let's see. F to open sync, and we're going to open the input file as read. And then, while, let's see. Ooh. I think it's, oh, you know what? I'm just going to use read file sync. It's not that long. The one way of reading the file that I'm trying to use is like you get a handle, and then you like read in the individual lines one by one. But the data here is actually, it's only 1,000 lines. It's not that long. So I'm just going to use read file, which read file will actually pull in the entire file as one string. You don't want to do this if you're dealing with a really, really long bunch of data. So if I knew this got up to hundreds of thousands of lines, I would probably just look up how to do the line by line because that uses less memory, but this should be fine. And then we're going to split it by the new line. That gives us our specific lines for line of lines. And then we have to actually split this. Item 1, item 2 equals line dot split, and we'll split that on the comma. All right, and what I'm actually going to do right now is I'm going to console log these to make sure that I've done it right. Let's see, this is probably me in the wrong directory. Now let's just see what we get. Okay. I mean, that looks correct. Just spot checking these to make sure they look okay. And I also, what I want to do, let's do this. We're going to say list 1. And we're going to append them, push. But I need to get the integer value of this. So I actually need to use parseInt. Item 1 and item 2. Cool. And then after this, we'll just log the lists just to make sure that, okay, yeah, those look numeric. Now, the next thing we got to do, according to this prompt, is we need to figure out the smallest number, second smallest. The easiest, I mean, we could actually loop through the list, find the smallest number, loop through the other list, find the smallest number, then loop through the list, find the second smallest number, etc. That would be, I feel like that would be an O of n squared operation, possibly. Might even be worse. What I'm actually going to do is I'm just going to sort the list. And I believe, oops, if I do this, this should just sort them in numeric descending order, and that does appear to have done that. And there we go. So this is actually, this runs in like O of n log n, I think, is the most efficient sorting algorithm we have, which is merge sort. Don't quote me on that. But it's just, it's a lot less code. No, I'm not going to merge them together. So now we're going to just run through list 1 and list 2 and just find the distances, because now we actually know they're all in the right order. So we know that this is the smallest, second smallest, so we can just go wild with that. And we're going to say, okay, I'm going to use an index. These two lists should be the same size, and I can verify that because I know that I had the same number of rows. All right, well, really, each row in the input CSV had an entry, hopefully. I don't want to scroll through the whole thing, but I'm just going to assume they are. If not, we'll get an error. But I'm assuming at this point they're the same size. So I'm going to use, not that, thank you. And you might notice I am using a little bit of tab 9, the AI, but I'm not letting it do the whole algorithm for me because I don't think it would understand that. But I am letting it kind of just do basic stuff, which is it's just a way you can, if you can save like 5 to 10 seconds by not typing out this whole thing and what it's giving you is correct, you might as well take advantage of it. Okay, item 1 equals list I. Item 2, distance equals, oh, you know what? So really the distance, there's two ways to do this. If item 1 is smaller than item 2, then you could subtract item 1 from item 2 versus, so actually I'll just write it out. So we could say if item 1 is greater than item 2, let's put it up here, then the distance equals item 1 minus item 2. We could probably actually do an equals there. Otherwise, the distance is item 2 minus item 1. That'll work. It's kind of a lot of code. So the other thing you could do is you could also say distance equals math.max, item 1, item 2, minus math.min. This is a little bit more confusing, but it accomplishes the same thing because this will get the bigger item and this will get the smaller item. The other thing you can do, because if you take two numbers, if I have 7 and I subtract 3, I get 4. But if I get 3 and I subtract 7, I get negative 4. So what I can also do is I can actually just say item 1 minus item 2 and then get the absolute value of it. And that actually, all three of these will actually should have the same effect. Let's actually just verify that, just for funsies. I know these should probably be const, because I'm not actually changing them. Oh, that's not what I want. So let's just take a look at these, and you know what? Let's run through them. And you can see these generally seem like they're all the same. I'm gonna go with this third one because I think it's the smallest amount of code. And that's just a fun way of doing it. And that's kind of what these advent to code things are for, is just to, have some fun with it. Okay, so now we want the total distance. Oops. And now total distance. I could have used a reduce on this as well. The reduce does give you the index of what you're looping over, so I could have reduced over this list and just had the output of that be the total distance, but I don't actually like that, the way that code looks. I think it's totally fine if you go down that route, but yeah. And now, wow, okay. Total distance, and let's see what we get. Okay, it's a big number. I have no idea if that's correct because there's just so many numbers. So let's just see here. What we could actually do is we could actually grab this sample because we know that that gives us 11. And let's just put in sample. And we'll do that same replace on it. And we'll just change this to use our sample instead. And that should give us 11. There we go. Cool. So that gives me more confidence that this is correct, just because these don't differ too much. What are we doing here? Okay, first of all, we're reading in the file, splitting it by line, looping over the line, getting item 1, item 2 by splitting the CSV, parsing them as an int because we're going to be doing integer operations. If we weren't doing integer operations, I don't know if I'd really bother. It's probably not that big of a deal, but integer operations do require ints. We sort them. This is important to get that first, second. The sorting is just the easiest way to do that. Then we loop over everything, get our items, get the distance, add it to our total distance, and there we go. So now, I'm going to come back here, pop that in there, and just see. It's the right answer. Oh, we're one gold star closer to finding the chief historian. So, anyway, I hope this is interesting. I'll try to do a couple more of these. I want to do all 25, but we'll see. We'll see if that actually happens. Have a good one, folks. I'll see you next time.